Hello everyone, this is Siddiqur Rahman and welcome to the fifth lecture of the second week. So let's begin. By the end of this lecture, you guys will be able to describe number system conversion. So let's move into the next slide. This slide represents the overall outline of this lecture. You guys will describe or you guys will know about too many things, such as overview of number system conversion. Next, number system. What is number system or what does the number system means in mathematics? Types of number system. Overview of positional notation. I repeat again, conversion of binary to decimal, example for concept, and so on. So let's move into the next slide. First, we need to know the overview of number system. So let's begin. Numbers can be represented in any of the number system categories like binary, decimal, hex, etc. Also, any number which is represented in any of the number system types can be easily converted to other. There are many methods or techniques which can be used to convert numbers from one base to another. They are binary to decimal, decimal to binary, binary to octal, octal to binary, and so on. So let's move into the next slide. From this slide, we may learn what is number system. So let's begin. The number system or the numeral system is the system of naming or representing numbers. There are various types of number systems in mathematics, such as binary, decimal, etc. Different number systems can be defined according to their base, or you can say radix, which is symbolized or designated by R, which can be right as follows: R is equals to 2, 8, 10, 16, etc., even 7 or 13. So let's move into the next slide. From this slide, you may learn what does number system mean in mathematics. So let's start with the definition. A number system is defined as a system of writing for expression numbers. It is the it is the mathematical notation for representing numbers of a given set by using digits or other symbols in a consistent manner. It provides a unique representation of every number and represent the arithmetic and algebraic structure of the figures. It is also allows us to operate arithmetic operations like addition, subtraction, and division. Well, the value of any digit in a number can be determined by the following steps, such as the digit, its position in the number, the base on the number system. So let's move into the next slide. Well, from this slide we may learn types of number system. So let's start. There are various types of the number system in mathematics. The four most common number system types are decimal number system, which has a base of 10, binary number system, which has a base of 2, octal number system, which has a base of 8, and last one, hexadecimal number system, which has a base of 16. Next. Well, from this lecture or from this slide, we may learn positional notation. So let's start. Positional notation, or you can say place value notation, or in another way you can say positional numeral system, denotes usually the extension to any base of the Hindu-Arabic numeral system or decimal system. More generally, a positional system is a numeral system in which the contribution of a digit to the value of a number is the product of the value of the digit by a factor determined by the position of the digit. Let's move into the next slide. Well, this slide represents a graphical representation. Sorry, I mistake this one. Not graphical representation, you can say the visual representation of positional notation. And in here there is a number or you can say there is a decimal number represented in figure, which is 1125, and after this number you can see that here is another base suffix number, which is 10, and which represents the base of the decimal. Well, and the individual digit like 1, 1, 2, 5, these are called individual digit, and individual digits are represent a individual position. And in above of this number you can see that there is a index which is represent, since it's a decimal number, so that's why we can represent the index are as follows: 10 to the power 0, 10 to the power 1, 10 to the power 2, and 10 to the power 3. Well, so let's move into the next slide. From this slide we may learn the first example of binary to decimal conversion. So let's begin with the question. Consider the conversion of the binary number 101 into its equivalent decimal number. For understanding, we solve this problem into tabulated form. So here is, or this slide represents a table, and there is 4-column heading, which is symbolized. First one is the serial number, next one is description, next one is MSB, and middle after MSB the column is blank, and last one and the most right one is LSB. And one question may arise in your mind, what is LSB and what is MSB? Actually, LSB stands for least significant bit. You guys already know what is bit, and MSB stands for most significant bit. Well, the second row of the table represents given binary number. We already know, or we already see that the given binary number is 101. After this row we can see there is a writing, and which is represents binary position. We already know the positional notation from the previous slide, so we don't have any problem regarding this issue. Since they are binary, since it's a position of binary, so since the third row of this table represents the binary position, as we know the positional notation from the previous slide, and it's and in this problem we know this is the number of binary, so the base of this number will be 2, and the position will be 2 to the power 0 from the right to left, 2 to the power 0, 2 to the power 1, and 2 to the power 2. Next row represents the first step of the conversion of binary to decimal. So first step will be multiply. Okay, multiply, and you see inside of the parenthesis, which is given binary number and the binary position. And here is the step for your understanding: 1 into 2 square, 0 into 2 to the power 1, 1 into 2 to the power 0. And the next row represents the product from the previous. Since we are multiplying the immediate rows from above, so that's why we get 4, 0, and 1. Next row represents the third step, and which will the addition of the founded product, so which is 4 plus 0 plus 1, and which will give us the a single number, which is 5. And we already convert the given binary number into the decimal number, or you can say the equivalent decimal number, and which is equals to 5. So let's move into the next slide. Well, from this slide we may learn another example of binary to decimal conversion. And if you see the question, you can notice that the example is a specific type problem, which is non-fractional type problem. Okay, so I hope you guys don't have any problem because you already done one example from previous side. Just say the formality for this example, and here is also the given number is a binary number 1 1 1 1 and 2 is the base of the given number, so that's why we represent as in this. Likewise, first 1 1 1 1 and most right one is LSB and left one is MSB. After that, the positional notation represents, which is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. And after this, we multiply the given binary number as well as the binary position on positional notation. That's why 1 into 2 to the power cube, 1 into 2 square, 1 into 2 to the power 1, 1 into 2 to the power 0. After that, we get the product value of the multiplication, which is 8, 4, 2 and 1. And after that, we can add these product values, which is 8 plus 4 plus 2 plus 1. After this, we'll get a single decimal number, which is 15. And this is the equivalent decimal number of the given binary number. I hope you understand this conversion of binary to decimal, and let's move into the next slide. And this slide also represents another example, or you can say another type of example of binary to decimal conversion. And if you see in the question, you may notice that in this problem, or this problem is a mixed type problem. And if you see the given binary number, you may notice that this is not the same in the previous slide. So here it is, this problem, the binary number of this problem is 1.1. So for your understanding, here is the solution of this problem. I hope there is no problem for your understanding. So let's move into the next slide. This slide represents the practice problem for what you are understanding in this lecture, which is binary to decimal conversion. So hope you will do it by your own. So let's move into the next slide. In the next lecture, you guys will know the conversion of decimal to binary. Next. So that's all for this lecture. Thank you so much for your attention. See you guys in the next lecture. Stay safe and stay at home. Thank you.